The force of gravity is one of the most important forces that we encounter every day that affects our lives. And we do know that the more massive an object, so if it has a greater mass, the greater the force of gravity on that object. So for example, here I have an apple and an elephant. The apple's going to have a much lower force of gravity than the elephant. And it turns out the force of gravity on the apple is 1.96 newtons. And the force of gravity on the elephant is 39,200 newtons. And they found, as they studied gravity, that there was a relationship where as I increased the mass of an object, the force of gravity increased by the same amount. And they developed a formula that the force of gravity, and this actually comes from Newton's second law, is equal to the mass of an object multiplied by the gravitational field strength. And that does come from F equals ma. And I'll just put my vectors on these. As far as the force of gravity goes, it's towards the center of Earth. So it is a vector because it is a force, and it would be in the down direction towards the center of the Earth. So both of these forces have a direction of down. So the force of gravity is equal to mass, which we would just measure in kilograms. And this G, there's two names that you can have for G. It is the acceleration due to gravity, but we can also, it is also sometimes called the gravitational field strength. So it could be either of these things. So this is the acceleration due to gravity that we saw in our motion of a falling object assignment. And it is actually equal to 9.8 meters per second squared in the down direction if there is no air resistance. So as long as there's no air resistance, all objects would fall at the same rate. So you could actually have a feather and a penny fall at exactly the same rate if there's no air. It can also be called the gravitational field strength. And it's just the gravitational field around a very large object like a planet. And it can also be given the units newtons per kilogram. So it could also be said to be 9.8 newtons per kilogram in the down direction. So we can actually take any object, and if we know the mass, we can just multiply it by that gravitational field strength or the acceleration due to gravity, and we can find its force of gravity. Now, I am using 9.8 as my acceleration due to gravity or gravitational field strength. And that actually is only for Earth. If I go to another planet, it's going to change because the planet might be bigger and have a higher force of gravity, or it might be smaller and have a lower force of gravity. And on the moon, the gravitational field strength is actually 1.6 newtons per kilogram down. So we could actually, if I know mass, I can find the I can find the force of gravity on Earth if I know by using this gravitational field strength, or on any other planet using another gravitational field strength. So let me just do one example for you of that. In this example, I want to find the force of gravity of a 25 kilogram dumbbell, both on Earth and on the moon. They've given me the gravitational field strength both on Earth and the moon. It's 9.8 newtons per kilogram on Earth and 1.62 on the moon. This may also be called the acceleration due to gravity, so just watch out for that. I'll put that in there as well. So we're going to start off by listing our givens and our requireds. I'm going to list the givens that I have here, which are the 25 kilograms. As soon as I see kilograms, I know that is a mass. And then I'm going to list my two gravitational field strengths. Next, I'm going to put what I'm required to find, which is the force of gravity both on Earth and the moon. So I'm just using my grasp problem solving method. So I just want to list those givens and requireds first. And then I'm going to analyze, which basically means analyze the formula or put the formula in. And the formula is that new formula we've done with F equals mg. And I'll start with Earth. So once I've got the formula down, I can sub in and solve. And I'm going to just put in my mass, which is 25 kilograms. And the gravitational field strength for Earth, which was 9.8 newtons per kilogram. Just remembering you might also see the meters per second squared if it's an acceleration, which is also perfectly fine. It gives you the exact same answer. And then you can multiply that. It will give you 245, and the kilograms will cancel out. So it will just be in newtons. And we are almost done our formula. So let me just take care of a few things. I'll cross out those kilograms because they're on the top here and on the bottom here. I'm also going to put a vector arrow over my force and gravitational field strength because the gravitational field strength has a direction. It's down towards the center of the planet or the moon. And I'm almost done. One thing that I am going to do is just check my rounding here. So I want to look at what I start with and what my final answer is. And I see that I have 25 kilograms, 9.8. So my final answer should have the same number of significant digits. These both have 2 digits. So I'm going to round this to 2. The 2, then I'll just keep this second digit here. Because there's a 5 next, it's going to round up and it will actually be 250. My final answer. And then I've got my force of gravity for Earth. I'm going to just do this exact same process, but for G, for the moon, I'll put in 1.62. So I've got my force of gravity for the moon is equal to 25 kilograms times 1.62. That gives me, if I round to 2 digits, that will give me 41 as my final answer. And that would be newtons down towards the center of the moon. The last thing that I want to do is just write a paraphrase. And I've done my problem and I've included all of my steps for problem solving. So I'll just quickly write a paraphrase or therefore statement. And you have finished your problem. one thing that I just wanted to go over, there's a separate little section on this in the lesson, but um, another name for the force of gravity is the weight of an object. So the weight of an object is the force of gravity. And one thing to be careful of, a lot of people confuse mass and weight, but they actually mean different things in physics. The mass is always the same no matter where you are. This is the amount of stuff in something. So that dumbbell has 25 kilograms of stuff in it. So no matter if it's on Earth or if it's on the moon, it's always 25 kilograms. But the weight, the force of gravity will change depending on what planet you're on. It could have a different force of gravity for the same mass. So mass is different than weight.